Yes. So in GOC, we discussed about what is hybridization, linearity, planarity. After that we discussed, so what are the types of carbons available in molecule. Then we also discussed degree of unsaturation. Okay. So next, keep reading. After degree of unsaturation, identification of lone pairs. So how to identify lone pairs present in a organic as well as inorganic molecule. So this can be useful to identify a neutral molecule lone pair or a charged molecule lone pair. Suppose see, if molecule is lone pair consisting species, so number of lone pairs, if you want to calculate, number of lone pairs is equal to G minus sigma plus pi bonds by 2. This is a formula. So what is G indicates? Group number. So what about the central atom group number? How many sigma bonds are surrounded by central atom? How many pi bonds are present around central atom divided by 2 will give one number. That number, suppose if it is 1 means 1 lone pair. One lone pair carry how many electrons? 2 electrons. This is that formula for neutral molecule. Especially for neutral we need to apply this. Okay. Now here I can write number of lone pairs. So here I am writing N. N is nothing but neutral. And here I am writing cation. C is nothing but cation. Number of lone pairs present in a cation. Here C, group number minus charge present on that cation. Okay, then followed by minus of sigma plus pi by 2. So what is this C indicates? Charge present on that cation. Charge of that cation. Suppose if it is plus 1, here you write down minus 1. If it is plus 2, here minus 2. Okay, aluminium plus 3 is there. Remove 3 electrons from aluminium group number. Okay, so this you will understand by taking example. First you write down the formulas. Okay, number of lone pairs for a anion. So here I am taking anion, that is A. Now group number minus anionic charge sigma plus pi by 2. This is a formula for anion. Here this A nothing but charge present on anion. And this C nothing but charge present on cation. So you write this C. C indicates charge present on cation, charge present on anion. So this is number of lone pair present on cation. And this is a charge of cation, charge of anion. Clear? So here you write like this. Charge on cation, and this is charge on anion. Anionic charge, cationic charge. Simple formulas to identify number of lone pairs in a given molecule. Now see the examples. See whether it is a neutral or charged molecule. Xenon trioxide. Neutral or charged? Neutral. See, there is no charge present on xenon trioxide, so it becomes a neutral. Now xenon belongs to which group? It is a neutral molecule in. So this is 8 group. How many sigma bonds? Every oxygen surrounded around xenon with double bond. There is 2 bonds between xenon and oxygen. Every oxygen forms a double bond with xenon. So every double bond carries sigma and pi. Sigma pi means how many sigma bonds? 3 sigma bonds, 3 pi bonds by 2. Then how much you will get? 8 minus 6 by 2. 2 by 2 how much? 1. 1 means how many lone pairs? 1 lone pair. Means this is a real structure of xenon trioxide. Xenon trioxide having 3 double bonds and 1 lone pair, like this. If I written 1 means it is number of lone pairs only on central atom, not on surrounded. So how many lone pairs are present on xenon in this molecule? Only 1. How many lone pairs present in this molecule? In this molecule how many lone pairs are present? 7 lone pairs. 2 ways of asking question. How many lone pairs present on central atom in a molecule, or else how many total number of lone pairs present in a molecule? In a molecule means total lone pairs we need to count. But if they ask how many number of lone pair present in central atom of a molecule means only this formula can help. Clear? See, around xenon, oxygen is there. Any charge here? No charge. On that time, every oxygen forms single bond and pi bond. That is sigma and pi. Here also sigma pi, sigma pi. So how many sigmas, how many pi's are present? 3 sigma, 3 pi. So that's why whenever if oxygen comes, just count 3 plus 3. So you will get 6. When oxygen comes, count 3 plus 3. Depends on molecule. Now see one more example I will show. You can understand clearly. Xenon tetroxide I am giving. Group number xenon 8. Now 4 oxygens are there. 4 sigma, 4 pi. So can I write directly 8? This is 8 by 2. Then value is how much? 0. Means central atom of xenon carry how many lone pairs? How many lone pairs? No lone pair. Tetrahedral structure. Xenon carry no lone pair. But what about surrounding oxygens? They carry 8 lone pairs. So if you know the central atom group number, and if you know how many sigma bonds are get surrounded around the central atom with pi bonds, then it is easy to identify how many lone pairs are present in central molecule. Okay. So will you work out this? Xenon difluoride, xenon difluoride, xenon tetrafluoride. You work out this. Xenon oxy dioxidifluoride. Just count how many sigma bonds are present, pi bonds present, and give the answer. So what about xenon group number? 8. Can I write 4? 8 minus 4 by 2. Then 4 by 2. How much you will get? How many lone pairs? 2 lone pairs. So xenon carry how many lone pairs? 2 lone pairs. How many lone pairs present in this molecule? In this molecule carry how many lone pairs? Every fluorine carry 3 lone pair. 4 into 3, 12. 12 plus 2, 14. Like that. 2 ways of asking. If they ask how many total number of lone pairs present in a molecule, means you need to count total. But if they ask how many lone pairs present on central atom of a molecule. So now we are applying this formula only for central atom. We are not applying for total molecule. Clear? Because central atom responsible for hybridization with terminals. Is it clear? Will you work out this too? How many lone pairs here? 3 lone pairs. And here? 1 lone pair. So ICL3, BRFI, now IF7. You take down as homework. H2O. Now sulfur dioxide, sulfur trioxide, thionyl chloride, then ammonia, nitrosyl chloride, NOCl. All are neutral or not? All are neutral. So just calculate the total number of lone pairs involved in that one. POCl3 like this, PCl5, PCl4. Then methane, any lone pair methane, carbon dioxide like this. All neutral molecules I am giving. Just write down number directly. Directly you can calculate. And if you have an idea about structure, easily you can calculate. If you don't have any idea about the structure, and if you know idea about only bondings, then you can calculate total number of lone pairs. But minimum group number is required. Group number of iodine 7, bromine it is also 7, BrF5, IF7. Here group number of oxygen 6. Here sulfur 6 here, nitrogen 5, nitrogen 5. Central atom I am saying. Central atom is phosphorus 5. Here also 5, carbon 4. CH2, COCl2. What is COCl2? Phosgene. Poisonous gas used in First World War. Phosgene. COCl2. ALH3, alene. ALH3 is called alene. Take down this, work out later. Here how many lone pairs you have? Iodine carry. Iodine belongs to which group? 7. 7 minus how many sigma bonds? Only 1. So 1 minus 1, 6. 6 by 2. 3 lone pairs. And here iodine 7. 7 minus 3. 7 minus 3, 4. 4 by 2, 2 lone pairs. Here only you can calculate directly. So here all are monovalent elements, there is no problem at all. How many lone pairs present on oxygen in H2O? 2 lone pairs. 6 minus 2, 4 by 2, 2. Clear? And here how many lone pairs present in sulfur dioxide? Sulfur 6 or not? 6 minus 4, 2 sigma, 2 pi. If any double bond is present between sulfur and oxygen, we need to count 2 sigmas, 2 pi. Okay, so here total number of lone pairs are how many? 6 minus 4 by 2, 2 by 2, 1. And here how many? 0. Sulfur trioxide perfectly planar. There is no central lone pair of electron on sulfur. Thionyl chloride. So sulfur is a central atom. C. Chlorine sigma, 2 sigma. And here is oxygen also having sigma. 3 plus 1, 4. So can I say 6 minus 4 by 2? Then how much you will get? 1. Every oxygen, especially if it is forms double bond, just count 1 sigma bond and 1 pi bond. Every oxygen sigma pi. So sigma pi 2 and here 2 sigma. 3 sigma 1 pi 4. Clear? Ammonia 1 lone pair. NOCl 1 lone pair. Will you calculate this? Here how many lone pair? 5 minus 3 by 2. 2 by 2 1. 5 minus 5 0. Very easy. Here only you need to calculate. No need to use that formula even. Okay, formula we can use orally, but directly you can write the number over here. How many lone pairs present in methane? 4 minus 4, 0. And here CO2, 4 minus 4, 0. No lone pair on carbon, in carbon dioxide. And here 4 minus 2, 2 by 2, 1. This is one lone pair, already lone pair 18. That is that lone pair. And here COCl2, carbon, 4 minus 4, 0. And here 3 minus 3, 0. Aluminium plus 3, third group element. How many atoms are surrounded? 3. 3 minus 3 by 2, 0. 0 or not? Yes, it is 0. Even you can apply for organic molecules even. Same content you can apply for organic molecules. If it is a neutral molecule or any charged molecule you can apply. So if I write like this, how many lone pairs present on carbon? How many lone pairs present on carbon? 4 minus 4. 4 bonds are present around carbon or not? See how many bonds present around carbon? 4 bonds. 4 minus 4. 0. So your number of lone pairs are 0. How many lone pairs present on oxygen? Just count here. 6 minus 2. 6 minus 2. 4. 4 by 2. 2. Here 2 lone pairs. Even for organic molecules we can calculate. Clear? Suppose see if I write CH3NH2. How many lone pairs present on oxygen? Carbon 0. Nitrogen? See, nitrogen fifth group element 5 minus 3, 2 plus 1 3, 5 minus 3, 2 by 2. Here how many lone pair? 1 lone pair. 1 means 1 lone pair. 1 lone pair means how many electron? 2 electron. They are most helpful for your examination. Okay? Now, if I write a carboxylic acid, C double bond O, OH, is it neutral? So what is the charge present lone pairs on carbon? 0, and here this carbon 0, and this oxygen. How many? 2 lone pair. Just count the formula. Use the formula. 2, and here also 2. Can I? This oxygen carry 2 lone pair. It also carry 2 lone pair. See, around oxygen 6 minus 2. How much? 4 by 2, 2. No need to apply delocalization resonance like that. Just how many are present? How many are present? In that, how many are delocalizing? How many are permanently present? That is secondary. But how many are present actually? In this total molecule, how many lone pairs are present? Total 4. Out of how many are delocalizing? How many are localized? That is secondary concept. But total molecule carry 4 lone pairs, in which 2 oxygen and remaining 2 on this oxygen. Clear? Suppose same molecule if I apply for acid chlorides. This is acid chloride. Now this chlorine carry how many lone pairs? 3 lone pair, very easy. So chlorine 7th group, 7 minus 1. See, sigma bond 6 by 2. Now here 3, and here 2. 5 lone pairs. Like that you can apply for all organic molecules. Urea carry how many lone pairs? Number of lone pairs present in urea. Number of lone pairs on urea. See, this is 1, here 1, and here 2, over. Very easy or not? So if you know this one, you can find Lewis-Dart structure. Next is Lewis-Dart structures only. There you can identify whether it is a real lone pair or imaginary lone pair, like that. Is it clear? Now, see, ICl2 plus, ICl2 plus. Now, what is the group number of iodine? 7. What is the charge on iodine? Plus. Means charge of cation, minus 1. I given that formula, see. Group number minus charge of cation. Plus 1 means, we need to write minus 1. Minus charge of cation. Minus charge of cation is what? 1. Don't write, sorry, here plus 1 is there, why you are writing minus 1? Don't ask this question. Group number minus charge on cation. 1 only I written. Plus into minus, minus I written. Then followed by how many total number of sigmas and pi's? 2 only. So 2 by 2. Then how much you will get? So 7 minus 1, 6. 6 minus 2. 4 by 2. How much? 2 lone pairs. Clear? ICl4 plus. So neutral molecules you take down as homework. So whichever you feel uncomfortable, that I am going to work. IF6, I3 plus, I3 plus, H3O plus, CS3 plus. You work out cations. How many lone pairs in ICL4? See, simply remember it is 7 or not? 7 minus 1, 6. 6 minus 4. 2 by 2, 1. Write down group number minus this charge. On the spot you will get the answer. Group number is 7. 7 minus 1, 6. 6 minus 4. 2 by 2, 1. Right? Easy or not? Means, in this molecule how many lone pairs are present? In this molecule, how many lone pairs are present? First, iodine carry how many lone pairs? One lone pair. Just now I calculated. So 1 minus 1, 6, 6 minus 4, 2 by 2, 1. 1 plus 12, 13. Every chlorine carry how many lone pair? 3. 4 into 3, 12. 12 plus 1, 13. If they ask total number of lone pairs, that is a different question. Be careful. That's why don't be hurry in attempting the questions. Count how many number of lone pairs present on central atom. If they mentioned central atom, on that time you calculate only for central atom, apply this formula individually. And if they ask how many total number of lone pairs are present, that is different question. Clear? Will you work out all? Here in this how many lone pairs? Just orally you say the answer. 0. Here? How many? 2 or 3? 2. H3O plus SO2 plus you just calculate. Okay? Just calculate the all cations. Then we will go for anions. ICl2 minus, ICl4 minus, IF6 minus, ClO4 minus 1, ClO3 minus 1, I3 minus, here hydroxide minus, SO4 minus 2, sulfato minus 2, SO3 minus 2, amide NH minus 1, NH minus 2, here N minus 3. So here we can take even CS3 minus, you know, aluminum hydride, lithium aluminum hydride, AlH4 minus 1. All negative charges. Now, when oxygen is there, just count sigma and pi. One oxygen, If one oxygen is present, it will give 1 sigma and 1 pi. See, here one oxygen is present or two oxygens? Two oxygens. Every oxygen will give 1 sigma and 1 pi. Two oxygen means 2 sigma 2 pi. Means 4. The answer is not 4. Sigma pi bonds are 4 here. Chlorine, 7th group element. 7 plus 1. 8. 8 minus 4. Why I am writing 4? Here this is 7th group element. 7 plus 1. 8. 8 minus every oxygen 1 sigma 1 pi. So I can say 8 minus 4 by 2. That is 4 by 2. Total 2. How many lone pairs in ClO2 minus 1? Chlorus, that is chlorus. This is called hypochlorus. Suppose if I write HClO2 minus, HClO2 minus, chlorous acid. Now here how many lone pairs present in this one? ClO4 minus 1. ClO4 minus 1. Chlorine 7. 7 plus 1. See, what is the group number? 7. Minus charge on anion. What is the charge on anion? Minus 1. Minus minus plus. 7 plus 1. 8. 8 minus here every oxygen 2. Just you multiply with 2. Because every oxygen will give 1 sigma and pi. So 4 into 2, 8. 8 minus 8 by 2, 0. No lone pair on chlorine. This chlorine carry no lone pair. This is called perchloric acid. Perchlorate. Perchlorate. Clear? This is perchlorate. Here how many lone pairs you will get? 7 minus 7 plus 1, 8. 8 minus 6 by 2. 2 by 2 means how much? 1. And here 0. Here you will get 2. And here this one. 7 plus 1, 8. 8 minus 2. 6 by 2. 3. See here initially 0, 1, 2, 3. This is called perchlorate. Chlorate. Chlorus. Hypochlorus. Clear? Now this molecule is given in exam. I3 minus. How many lone pairs present in I3 minus? Central atom of iodine. How many lone pairs are present? CSR question, that is inorganic question actually, in the form of lone pairs, but actually we'll deal with here itself. Iodine group number 7. 7 plus 1. 8 minus 3 or minus 2? Minus 2. Because already one iodine is center, remaining two iodines are surrounded around iodine. Generally in fast you will remove minus 3, then you are going to confuse. Sorry, I am getting odd number, what to do? One is central atom, remaining two are surrounding atoms. Okay? 7 plus 1, 8. 8 minus 2, 6. 6 by 2. 3. So, now 3 lone pairs present around central atom of iodine. Clear? Or is it complicated calculations? Any BPC student is there? First you, only one. I think remaining all are MPC. Raise your hands freely. I won't ask any mathematical questions. Remaining all are math students. In your intermediate or degree, do you have math specialization or not? That's what I am asking. You know mathematics? So try to learn tables up to 20. Be prepared. First you has to be very confident in mathematics. Whatever number comes, that you need to remember. Addition or division or subtraction or any multiplication or fraction addition, fraction division, that number first you need to believe. You need to believe your mathematics first. Right? How many lone pairs present in sulfato? SO4 minus 2. 0. 6 plus 2, 8. 8 minus 8, 0. Over. Every oxygen 2. in which 1 sigma 1 pi over answer. Clear? Will you work out remaining all? How many lone pairs present in n minus 3? 3 or 4? See, nitrogen which group element? Fifth. 5 plus 3, 8 by 2 directly. There is no sigma, there is no pi. No need to think about sigma. Sir, no sigma, no pi, what to do? If it is not there, no use. Directly 8 by 2. 8 by 2, 4. So this carry 4 lone pair. N minus 3 carry 4 lone pair. Okay? CS3 minus carry how many lone pair? 1 lone pair. Aluminium hydride, AlH4 minus. How many lone pair? AlH4 minus. How many lone pairs? Aluminium belongs to which group? Third group. 3 plus 1. 4 minus 4. 0. Don't think minus 1 every time it is not a lone pair. Now that electron bonded to hydrogen and aluminium empty orbital. Hydrogen, aluminium empty orbital having a lone pair. Now O minus 2. What is O minus 2? Monoxide. Sodium monoxide, like that. Suppose O minus 2 is given. Suppose if I charge balance with sodium, sodium carry plus 1. This 2 comes here. So sodium monoxide. Suppose if it is a secondary group element, beryllium. Beryllium plus 2, minus 2. So it is beryllium monoxide. This is monoxide structure. Monoxides are basic in nature mostly. First A group metal oxides are basic in nature. If you dilute them, you will get corresponding hydroxide. Sodium hydroxide, beryllium hydroxide, etc. This is called monoxide. O minus 2. What is O2 minus 2? O2 minus 2. Peroxide. O2 minus 1. Superoxide. This is superoxide, peroxide, monoxide. What is the charge on peroxide? What is the charge on peroxide? O2 minus 2. Minus 2. 2 oxygens carry minus 1, minus 1. Superoxide. 2 oxygens carry minus 1. Means 1 by 2, 1 by 2. Minus 1 by 2, minus 1 by 2. This is superoxide. This is peroxide. This is monoxide. What is hydrogen peroxide? H2, O2. H2, this 2 comes here. H2, O2. What is sodium superoxide? What is sodium superoxide formula? NaO2. You know crisscross method, charge multiplication. Suppose if I write Na plus, if I write Na plus, this minus comes here, plus comes here below. So remove this plus and minus, then NaO2. See the monoxide, Na2O2. Na2O is called sodium monoxide. NaO2 is called sodium superoxide. Clear? So count total number of lone pairs in O minus 2. Monoxide. How many? 4. Here how many lone pairs present in O minus 2? Total. Otherwise you calculate only one oxygen. See, this is hydrogen peroxide, you can write like this. This is minus 1, minus 1. This oxygen carry how many lone pairs? This oxygen carry 3 lone pairs. Every time don't apply that formula. Don't only fix with formula. Common knowledge also you need to apply sometimes. Right or not? See, if I say try to calculate the speed of train means you should not stand on tracks and calculate the speed. Train is coming in front of you. You want to calculate the speed. That is not a correct process. Where you need to stand first? Where you need to stand? I say try to calculate the speed of the train. then you have a biggest question, where to stand. Then you are standing in front of a train directly. On a tracks you are standing and you are calculating speed. You are a brilliant student, but not using common sense. First, what is required? For chemistry required common knowledge. Human knowledge, common knowledge is sufficient. Okay, don't think that you are using a biggest part in your mind over here. You are not using nothing. Okay, common knowledge is sufficient for attempting this kind of questions. So don't think you are learning a complicated concepts. Simple logical concepts are required. Group number is sufficient, and whichever atom having a bivalency, trivalency, based on that we can calculate number of lone pairs. Here how many lone pairs are present? 3. Here how much? 3. Total how many lone pairs? 6 lone pairs. That's it. Based on the question you need to decide the answer. So take down that all negative ends, work out later. All are same. So this is that question, right? The number of lone pairs, present in I3 minus is 3, 4, 9, option D 5. This is CSR question. In inorganic chemistry actually this will come, but calculation of lone pair if you learn in organic it will be clear. Both organic and inorganic molecules will be very easy for you. How much? 9. See the question clearly. The number of lone pairs present in I3 minus. In I3 minus was asking, not mentioned central atom. In this molecule how many lone pairs are present he was asking. He was not asking central atom. Many students given 3 because it is first option. Your formula matching, option matching, you won't see other options. Be careful. Easiest question you can do mistake very easily. You feel very happy. Number of lone pairs means you feel very happy. Molecule is given. Apply the formula. We are getting this. Number is also matching. You won't check more. That's why don't believe CSR questions. First you pay attention. If question is very easy, pay attention. Read once and twice. Okay. So that is about calculation of lone pair. So it is not so much important, but suddenly you can expect a 2 marks question from here. Okay. Is it okay? Already this I given I3 minus, you will get number 3. That is for central. What about surrounding 2 iodines are there? Above iodine 3 lone pair, below iodine 3 more lone pair. Total 9 lone pairs. Clear? Next topic, calculation of sigma and pi bonds. How to calculate sigma bonds and pi bonds in a given skeleton. Calculation of sigma and pi bonds. Sigma bond calculations and pi bond calculations in a given molecule. Suppose see, if you want to calculate number of sigma bonds, first number of sigma bonds we are calculating. If I want to calculate for alkane, Remember, number of carbons multiplied with 3 plus 1. This is the formula. Alkane. If you want to calculate number of sigma bonds in alkane, what is the formula? First you need to confirm it is alkane. How to confirm alkane? What is the formula of alkane? CnH2n plus 2. This is a general formula. Suppose say I want to take one butane, C4, 4 into 2. 2 into 4 how much? 8 plus 2, 10. So C4H10, how many sigma bonds are present? We need to calculate. C4H10 is an alkane. C4H10 alkane or not? How many sigma bonds? 4 into 3, 12 plus 1. How many? 13 sigma. Is it butane or not? How many hydrogens are present? 2 into 4 how much? 8 plus 2, 10. 10. So this 4 you need to substitute here because it is alkane. How can you confirm it is alkane? See, carbon number you double the carbon number, add plus 2, that becomes hydrogen. Double the carbon number, and if you leave it, that is alkene. Double the carbon number. Double the carbon number and add 2 hydrogens, that is alkane. Suppose if it is a alkane, once if you confirm it is alkane, take carbons and substitute here. Here 4 carbons are there. 4 into 3, 12. 12 plus 1, 13 sigma bonds are present here. So this carry 13 sigma bonds. Now here, I am writing this molecule. How many sigma bonds are present here? How many? Is it alkane? How can you say it is alkane? All sigma bonds are present. Right? So how many sigma bonds are present? 1, 2, 3, 4, 5, 6. 6 into 3. 18 plus 1. 19 sigma bonds are present. Suppose if I say decane. Decane. Decane means what? 10. 10 into 3. 30 plus 1. 31. Now, hectane. What is hectane? That is hectane only, not heptane. I am clear, that is a hectane. First, you should know what is hect. Hect means 100. It is 100. 100 carbons are there here. So what is the alkane general formula? If you substitute in this one, C100, you substitute in this one, 2 into 100, 200 plus 2, 202. So C100, H202. Hectane means what? 100. 20. If alkane carry 20 carbons, see if 10 carbons are there, what is that? Dec, level carbons, undec 12, dodec, tridec 13. Like that, if you keep on going, 17, heptadec, nonadec, then 20, ecos, ecosane, 20 is ecos, 21 henicos, 22 is diecos, like that. 30 is triacant, 40 tetraacant, 50 pentaacant, 60 hexaacant. Fullerenes, you know fullerenes, that is belongs to C60. Okay, right now hectane, kili, you know killians, 1000 is killians, diluents, 2000. So this is hectane. Hectane means 100 carbons. 100 carbons consisting alkane, how many sigma bonds are present? 100 into 3, 3 plus 300 plus 1, 301 sigma. Clear? So if it is an alkane, end with ANA, NANA, like that. Clear? Right. Suppose if it is alkene, how to calculate number of sigmas? Number of carbons multiplied with 3 minus 1. What is alkane general formula? CnH2n, right? Suppose see if it is C4, how many hydrogens should I write if it is alkene? Just listen. Don't write, just listen. C4, how many hydrogens should I write? Double the carbon number. Double the carbon number, how much? 8. If anywhere, if carbon number doubled and the doubled number attaches to hydrogen, that is belongs to alkene. If you double the carbon number, then if you add plus 2, then that is belongs to alkane. Double the carbon number, how much? 8. 8 plus 2, 10. Alkane. Indirectly I am applying the formula only. Now how many sigma bonds you are going to expect? 4 into 3, 12 minus 1, 11 sigmas. Now 6 I am writing, here 1 double bond I am writing. Now how many sigmas are expected? That's why tables, you should be very strong. 6 into 3, 18 minus 1, 17 sigma. Okay, now I am using decene. Decene. Decene means what? How many carbons? 10 carbons. So 10 into 3, 30. 30 minus 1, 29 sigmas. So can you apply for alkyne? What is alkyne? Carbon, carbon, triple bond. So for this, see, number of carbons multiply with 3 minus 3. Here minus 3. So what is alkyne triple bond formula? CnH2n minus 2. You work out up to here. You work out this example. C4, can I say S6? C4, 2 into 4, 8 minus 2, 6. C4 is 6. If you double the carbon number, alkene. After double, if you remove 2 hydrogens, alkyne. If you add 2 hydrogens, alkane. So your target is alkene. Take alkene carbon, double that number. Double that number. Suppose if 14 carbons are there, 28. Add 2, alkane, remove 2, triple bond. Very easy to remember. Suppose if 7 carbons are there, what is alkene? If 7 carbons are there, what is alkene? C7H14. Add 2. Add 2, alkane. 14 means 16. Remove 2, 12. 12 means alkane. So if you remember alkene formula, very easy. Add 2, remove 2. If you remove 2, you will get triple bond. Add 2, you will get single bond. Right or not? From double bond, if you remove 2 hydrogens, you will get triple bond. From double bond, if you add 2 hydrogens, you will get single bond. Simple. Calculate number of sigma bonds in C4S6. Decane. Will you calculate? Suddenly 2 marks questions will come. Rare case that too. But you should be familiar, and especially in JL and any DL type of examination, this kind of basic question they will ask suddenly. On that time what happens, see, if you know the formula structure clearly, then only you can attempt. Be careful. How many sigma bonds here? 4 into 3. 12 minus 6. 12 minus 6 or 12 minus 3? 12 minus 3. You apply this formula. Don't apply this formula. 4 into 3. 12. 12 minus 3. 9. So this is 9 sigmas. Will you work out remaining two? Cycloalkane, number of carbons multiply with 3 only. Cyclohexane, cyclopentane, butane, and here cyclopropane. How many sigmas are there? Here how many sigmas? 6 into 3, 18 sigmas. 5 into 3, 15 sigmas. 12 sigmas. That is 9 sigmas. Suppose if any benzene is given, number of carbons multiply with 2. This is benzene. Naphthalene, number of carbons multiply with 2 minus 1. This is naphthalene. Anthracene, here also remains same, number of carbons multiply with 2 minus 2. Here only fusings we need to apply. This 1, 2 indicates that fusings. How many fusings present around benzene? That is this one. Suppose if I take benzene, benzene carry how many sigma bonds? 6 into 2. Don't remember that formula. Even slowly also we can calculate. Every carbon hydrogen, carbon carbon, sigma bond only. Carbon hydrogen sigma, carbon hydrogen sigma. How many hydrogens are there? 6. 6 hydrogen, 6 sigma. Every carbon carbon sigma bond is there. 6 plus 6, 12. Otherwise 6 into 2, 12. So we can apply even directly like this, 12 sigma. Now see here I am writing minus 1 or not? Now this is naphthalene. Right? Double bond, like this. Here how many fusings present between two benzenes? Only one fusing or not? This is called fusing. Two attached phases is nothing but a fused phase. Here one fusing is there. That's why minus 1. Suppose if I take anthracene. This is called anthracene. How many fusings are there? Here one fusing and here one more fusing. Total 2. That's why it is minus 2. Here how many sigma bonds? How many carbons present in naphthalene? 10. 10 into 2. 20 minus 1. 19. And here? First how many carbons are there? 14. 14 into 2. 28. 28 minus 2. 26. Clear? You need to remember these formulas. See how many sigma bonds are present in this molecule. Just remember this molecule name. This is called toluene. Toluene, how many sigma bonds are there? Benzene, every benzene? 12 or not? Benzene, 6 into 2. So up to this bond, see, up to this bond it is 12. Carbon attaches to how many hydrogens? 3. 12 plus 3, 15. Like this we can calculate. Okay. So how many sigma bonds are present in this one? This is CS3. What is this? Xylene. Orthoxylene. How many? That is 18. Here this is 15, add methyl. Then how much? 18 sigmas. This is phenol. How many sigma bonds on phenol? Is it phenol? Phenol carry how many sigma bonds? 13. It is 13 sigma bonds. This is cumene. How many sigma bonds in cumene? Find the number of sigma bonds in cumene. Name they will give, be careful. Question is very easy, but if you don't know the structure, you will lose marks. That's why these questions are important. They will give, find the number of sigma bonds in cumene. Like this they will give, name. See here, how many carbons are there outside? 1. Saturate or unsaturated? Saturate. Outside how many are there? 2. 2 saturate or not? Here how many outside? 3. 3 are saturate or not? Then see, from here to here how many? 3 difference. 15 plus 3, 18. 18 plus 3, 21. See, you will get 21 answer. $21 you are getting or any less? Here one hydrogen is there. This is one mistake. You will miss this bond, you will miss. That bond, one sigma bond. This is methyl. Up to here how many? 12. Here hydrogen. 13. 2 carbon bonds. 15. Methyl. 15 plus 3, 18. 18 plus 3, 21. How many sigmas? 21 sigmas. See, outside here how many carbons? Apply the logic. You need to apply the logics every time. You need to focus on how SAR is writing. Outside 1 saturate, okay, 12 plus 3, 15. Now 2 saturate carbons are given. Now 3 carbons are there, all are saturate. Now see, apply the same logic. I am writing 3 carbons like this. Here I am writing 3 carbons like this. Is it all are saturate? All are saturate or not? Now you will get same 21. See, mesitylene. This is mesitylene. This is mesitylene used in GC2. Mesitylene is the compound which is used in Grubbs catalyst second generation. GC2 it is used. How many sigma bonds? First, 21. Here how many outside? 1 saturate. Here how many outside? 2 saturate. Here how many outside? 3. Here also 3. Okay. Now, here I am writing methyl and here also I am writing methyl. 2 methyls I am writing. Is this all are saturate or not? Now you need to guess the answer. This is called urine. How much? 24. 21 plus 3, 24 sigmas. Your name is also important. Now, actually we are targeting names. Some organic molecule names you need to remember. That's why I am focusing. Okay. So this is durine. You remember this. This is especially asked in C13 NMR. How many different C13 signals will given by durine? Like that questions they are asking. Okay. Now, how many carbons are present outside here? Here how many outside? 4 are saturate, 1 saturate, 2 saturate, 3 saturate, 4 saturate. Now 4 saturate. This is called parathymine. Parathymine. How many sigmas? Very easy. 24. So who is reference now? Benzene. That's why this formula is written separately. Clear? Up to this bond, remember, is it benzene bond or not? Up to this bond, just 12. Up to this 2. These 2 bonds 12. 12. 12 plus 3, 15 plus 3, 18. Up to this bond 12. 12 plus 3, 15, 18, 21. Like that. You need to target benzene attached bonds first. This is OHCS3. This is called cresol, orthocresol. You know, cresol glasses made by cresols. Orthocresol meta, cresols like this. This is styrene. Styrene. Here double bond and here it is speech. What is this? Stilbene. Stilbene. 2 benzene rings. This is catechol. This is resorcinol. Your 2OH at para position. This is quinol. Catechol, resorcinol, quinol. Same. They are position isomers. Same molecular formula but different in their position. Okay. Here this is, what is this? Benzaldehyde. I am not writing name, benzaldehyde. What is this? What is the name of this molecule? Acetophenone. Acetophenone. Suppose if I write benzene over there, one more benzene if I write, C double bond OPH. What is this? Benzophenone. Benzophenone. Leave some space below, write number of sigmas. This is called benzoic acid. Here COOH and this is OH. This is aromatic ester. If I use the word aromatic ester, this one. In aromatic esters, single bond oxygen attaches to benzene. It is used in freeze rearrangement. Suppose if benzene attaches to carbonyl group, that won't involve in freeze rearrangement. If I use the word aromatic ester, this is a skeleton. Aromatic ester. Okay. So in aromatic esters, benzene ring attaches to single bond oxygen, not on carbonyl carbon. So we can say phenyl acetate. That is actually phenyl acetate. What is the name? This one? Salicylaldehyde. Then what is this? Salicylic acid. You need to remember these names. Salicylic acid. Here? Phthalic acid. If I write this acid here, isophthalic acid. If I write here, terephthalic acid. The names are not required. You focus on phthalic acid. Now what is this? Phthalimide. Gabriel phthalimide reaction. Preparation of primary amines done by using this. Phthalimide. This is used in freeze rearrangement. By watching the organic molecule, you need to recollect any famous reaction. That is a way of developing subject. Then molecule name will be remembered. Name reaction also you can remember. Now focus is not sigma bonds. Now indirectly I am giving some molecule names. Clear? Major molecule names I am giving, which are going to repeat regularly. So this is called phenyl acetate, or also called aromatic ester. If I use the word aromatic ester, only this one. Suppose see, this is not a aromatic ester. Suppose if benzene attaches to C double bond O and if oxygen attaches to methyl, is it two are same? This and this both are same? No, this is not aromatic ester. This is not involved in freeze rearrangement. Only this one can involve. See, is it a carbonyl group? Carbonyl group is attaches to methyl, but right now carbonyl group is attaches to benzene. If carbonyl group is attaches to methyl, and this is called ethereal oxygen. This is called carbonyl oxygen. If ethereal oxygen attaches to benzene, then only it is called aromatic ester. Aromatic esters involve in only one reaction, freeze rearrangement. So we can prepare these molecules. Here you will get OH and this acyl migrate from here to here. So orthohydroxy carbonyl compounds or ketones we can prepare. This acyl migrates from here to here. You can also migrate from ortho to para. Ortho is predominant over para. Just calculate number of sigmas. Will you? Will you calculate? Here how many sigma bonds are expected in cresol? 16. Only few examples I will explain, remaining you work out. This is 16. How many sigma bonds in styrene? How many? 16. Stilbene? Don't see others' faces. Whatever you are getting, you say the answer. Every benzene 12. Up to here 12. 12, 12, 24. 2 hydrogens are there. 2 hydrogens. 26. Here one more sigma. 27. Between carbon-carbon double bond, one sigma bond is present. So now it is 27 sigma. Catechol. These all are same. 14 sigmas. Benzaldehyde. 14 sigmas. This one. How much? 17 sigmas. You calculate. This all you calculate. So this is one famous molecule used to prepare in benzene. What is this? Orthoaminobenzoic acid is called. Anthranilic acid. This is called anthranilic acid. Anthranilic acid. Orthoaminobenzoic acid on treatment with nitrous acid, you will get a corresponding benzene, a decarboxylation reaction. There you will expect a benzene. Orthoaminobenzoic acid is called anthranilic acid. Clear? Will you work out all? Only names are important. So these names I am not going to write next time. Just you need to revise. Few molecules only given. So some more I will give based on the concept. Okay? Number of pi bonds. Yeah, this is simple formula. Already we discussed. So number of pi bonds is equal to 2n1 plus 2 minus n2 by 2. This is the formula. n1 is equal to what? Number of carbons. What about n2? Number of hydrogens. n1 is carbons, n2 is hydrogens. Where you will observe this? du. du formula also responsible to give number of pi bonds, but this is applicable for open chain only. Don't apply this formula for rings. Okay? Number of pi bond calculation applicable only for open chain. Don't apply this for rings. Rings we can't apply. Suppose see, if I say C4H6, so how many number of pi bonds are possible? In this formula, how many are possible? Maximum. C4H6 carry how many pi bonds? So 2 into 4 plus 2 minus 6 by 2. How much you will get? You will get how many pi? 2 pi. 8 plus 2. 10 minus 6. 4 by 2. 2. 2 pi bonds are possible. 2 pi bonds means you can write like this. By using this formula, for a given molecule, you can create maximum 2 pi. That is the meaning. Maximum you can create 2 pi only. By using this formula I am saying. Suppose if you create a ring, one pi bond will be reduced. See what is the du in this one? 2. Suppose if I write 4-membered ring and one double bond. How many pi is here? How many pi bonds? Only one pi bond. Formula matching? Formula matching. But see, number of pi bonds, by using this one we are getting 2 pi. But actually in rings how many you are getting? Only 1 pi. So don't apply this formula for rings. Apply only for open chain. So this is formula for calculating any molecular formula will give maximum how many pi bonds. This molecular formula can give maximum 2 pi. More than 2 pi not possible. Less than 2 pi possible. Less than 2 pi. No pi also possible. Suppose see if I create a 4-membered ring. 4-membered ring, 2 rings I am creating. Any pi bond here? Formula matching? Formula matching but no pi bond. So what actually this formula reveals? This formula is saying that number of pi bonds calculation formula is saying that with a given molecular formula, how many maximum pi bonds you can create. How many maximum pi bonds you can create. Only that can be explained by this formula. Maximum number, not more than maximum. Minimum is possible definitely. Maximum is 2 means, what about minimum? 0. So if you are getting 2 pi means can you get 1 pi? Possible. 0 pi also possible. 0. So this is a formula for any molecular formula to give maximum pi bonds. How many maximum pi bonds given by this formula means apply same du formula, you will get maximum pi bonds. Is it clear? Now see, here I am writing C3H4. C3H4. How many maximum pi bonds you can create? How many? See, 2 into 3 plus 2 minus 4 by 2. How much you will get? 2 or not? 2 pi. 2 pi means can I write a triple bond and methyl? Can I write even aline? Are you able to understand or not? Here how many pi bonds I can write? 2 pi. Maximum. Can you write more than 2 pi? See in this, can you write more than 2 pi? Can you write more than 2 pi? Say I am writing more than 2 pi. See, if I write triple bond, possible? How many pi bonds are there right now? 1, 2, 3. 3 pi bonds are there. If I write one more pi, total how much? 4 pi. Actually 4 pi is there, but I am saying maximum 2 pi. How it is possible? See the formula. Formula will not match. Be careful with formula. If I write triple bond, formula matches? No. With respect to this formula, maximum 2 pi you can write. That is the intention. Clear? So don't think, sir, I want to create one more double bond, one more pi bond like that means you can create, but formula will not match. Suppose see, if this is a molecule, how many carbons, how many hydrogens are there? 4 carbons, 6 hydrogens. If I put a triple bond, how many carbons, how many hydrogens? 4 carbons, how many hydrogens? 4. 2, 3, 4. C4, H4. Formula changing or not? That is the specialty of this formula. So if you remember this formula, 2 advantages will be there. You can calculate du and you can isolate variable number of isomers. It is same way you can also identify how many maximum double bonds can be created for a given molecule. So maximum double bonds possible in open chain. Rings it is not possible. So when you keep on creating rings, what happens? If rings increases, pi bonds decreases. Here no ring, more pi bonds. If I create one ring, one pi bond decreases. If I create 2 rings, no pi bond. Try to understand the concept. As number of rings increases, what happens to pi bonds? Decreases. So if you want to create maximum pi bonds, which is better, open chain or rings? Open chains. It will helpful in HNMR. In HNMR they will give 4 options and they will ask HNMR signals. Clear? Right. C6H6. Sai? Itra. Voice check, sir. C6H6, how many? 4 or 3? But benzene having 3 pi bonds or not? This is a formula for calculating maximum number of pi bonds possible. Maximum number of pi bonds possible. So, your number of pi bonds is what? 4. So, 4 means 1, 2, 3, 4, 5, 6. You can put one triple bond here. You can also put one more triple bond here, anywhere. Okay. Now, C8H12. How many pi bonds possible? 3 pi, right. This is 4 pi and this is 3 pi. Take one 8 carbon open chain skeleton. Write open chains only. Don't create any rings. Okay. You can create ring, but don't introduce the double bonds in ring. Possible? Right. So that is about sigma bonds and pi bonds. Next topic, Lewis dot structures. Dot structures are Lewis dot structures. So you need to be careful here how to write charges, lone pairs, how to identify lone pairs, everything will be cleared in this concept. Lewis dot structures to identify the exact charge of a given molecule. Dot structures also called Lewis dot. Suppose if I take carbon, nitrogen, oxygen, halogen, hydrogen. So I want to write valency. What is the valency of carbon? 4. Nitrogen? 3. Oxygen? Halogen? Hydrogen? 0. Right? Or 1? What is the valence of hydrogen? If it is 0, we can't write hydrogens over there. What is the valency of helium? 0. That's why they won't participate with bonding with any element. Neon? 0. 0 group elements, that's why they given as 0. What is the meaning of 0? What is the meaning of 0 I am saying? If somebody says you are 0, what it means? If somebody says you are a 0 means, what actually it means? In any direction they explain, you won't understood, that is the meaning. Any direction, faculty explaining this direction, this direction, whatever direction you explain, you will understand same thing. That is the value of 0. 0 means whatever he was fixed, that is enough. But whatever you explain, he won't accept. Same thing they will understand. So 0 means no bonding. Nothing. No bonding in that one. Now what about lone pairs? How many lone pairs are possible here? Carbon. How many lone pairs present on carbon? 0. Nitrogen. 1. Oxygen. 2. Halogen. 3. 1, 2, 3. Hydrogen. Can I write 4? 0. Suppose if they given hydrogen H2, how to write Lewis dot structure? Remember, first you write down hydrogen, here 1 electron. Okay, here one more hydrogen I am writing. Between two hydrogens, how many electrons are present? 2 electrons. Write down 2 dots. That is it meaning. It is a normal structure, it is Lewis dot structure. Clear? Suppose if I write X2, what is the meaning of X2? Halogen. So now this is halogen, here one more halogen. Between two halogens, how many electrons are present? Between two halogens, how many electrons are present? 2 electrons. Every halogen, how many lone pairs are present? 3 lone pairs. 1 lone pair, 2 lone pair, 3 lone pair. Here 1 lone pair, 2 lone pair, 3 lone pair. If I write cross symbol, lone pair. If I write dots, bond pair. So now this is a bond pair present between two halogens. So if 2 electrons are present between two halogens, is it a single bond or double bond? Single bond. Suppose if I write 4 electrons, double bond. Clear? Suppose if I write O2, O2, how many oxygens? 2 oxygens. Between 2 oxygens, how many bonds are possible? 2. 2 means how many electrons? 4 electrons. 4 means it is a double bond. Then this oxygen carry how many lone pair? 2 lone pair, and here also 2 lone pair. Now N2. Write Lewis dot structure for N2. How many bond pairs, how many lone pairs you need to calculate. In this molecule, how many bond pair electrons are present? How many bond pair electrons? 4. How many lone pair electrons? Lone pair electrons 8. Be careful. I am not asking how many lone pairs. Lone pairs are 4, but lone pair electrons are 8. 1 lone pairs, 2 lone pair, 3 and 4. Lone pair is different, lone pair electrons are different. If 4 pairs are there, 8 electrons. Clear? Now N2, how to write N2 Lewis dot? First write down one nitrogen, then write down other nitrogen. First you confirm whether triple bond or double bond. Triple bond. Triple bond means how many electrons? 6 electrons. 1, 2, 3, 4, 5, 6. Then each nitrogen carry 1 lone pair, here 1 lone pair. Easy? Now it is easy. Now we are not entered in still. Normal structure we are writing into Lewis dot. Suppose if I write methane, how to write Lewis dot structure for methane? Write Lewis dot structure of methane. Over. How to write first carbon? Here 2 electrons, 2 electrons, 2 electrons, here 2 electrons. This 2 electron to this hydrogen, hydrogen and here hydrogen. Right? Suppose I want to write Lewis dot structure of ethane. How to write Lewis dot structure of ethane? Write Lewis dot structure of ethane. How to write first carbon? How many electrons between two carbons? 2. Then here 2 electrons with hydrogen, 2 electrons hydrogen, 2. 2, 2 and this is 2. So if any festival comes, you draw in front of your house these Lewis dot structures. You will get first prize. Especially Dasra, on that time especially local festivals are there. You take benzene or anyone and go for dots, dot structures will be there. So in front of your eyes, if you create Lewis dot structures, you will get first prize. You done a different molecule, don't write that points. I am giving a rough example. Suppose see if I write carbon carbon double bond, what is the Lewis dot structure? Carbon carbon triple bond, what is the Lewis dot structure? Then one example of aldehyde you can take with one oxygen, organic molecule oxygen. So here can I write carbon with 4 electrons and carbon with 2 electrons hydrogen, 2 electrons hydrogen, and here also 2 electrons with hydrogen, 2 electrons with hydrogen. Is it right? Now here 2 carbons, write down 6 electrons, and here 2 electrons with hydrogen, 2 electrons with hydrogen. Don't put any bond, that's it, only electrons you need to write. And here carbon 4 electrons with oxygen, 2 electrons with hydrogen, here 2 electrons with hydrogen, and oxygen carry lone pair like this. Don't put any bond, only dots you need to write. That's why it is called dot structures. Here we are putting bonds, here we are writing dots. This is called formaldehyde structure in case of Lewis dot. Okay, now see, I will give one molecule. See, what is the charge on nitrogen? What is the charge on nitrogen? How many nitrogens are there? 2. 2 nitrogens. Out of 2 nitrogens, is it 2 nitrogens are 0 or plus or minus 1? Plus 1 minus 1 possible or not? If I write plus 1 minus 1, it becomes 0 or not? N2 0, nitrogen is 0. You can write 0 0 possible. Plus 1 minus 1 possible. Suppose if I write minus 1 minus 1, minus 2 you will get. That is not possible. Plus 1 plus 1 plus 2. So only 2 possibilities. What is that? Either 0 0, otherwise plus 1 minus 1. Which is correct? Either 0 0 or plus 1 minus 1. Is it 0 0? 2 nitrogens having 0 0 charge, or both nitrogens having plus 1 minus 1? So just calculate. I will give one formula, formal charge. You know formal charge? Lewis dot structure means you need to learn about formal charge. Just listen. So here I am using formal charge. Formal charge represented by Fc is equal to. So here valency of corresponding atom or group number of atom. Valency. First valency. Next number of non-bonding electrons minus bonding electrons by 2. This is a formula to calculate formal charge. What is the meaning of formal charge? The charge, exact charge present on atom in a molecule. See, now we written a Lewis dot structure. We don't know they have charge or not. So if you want to confirm charge, whether they have 0 charge, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. So the real charge present on atom is called formal charge. Whether it is a 0 or minus 1 or plus, depends on number of electron. So the charge present on atom in a Lewis dot is called formal charge. So V is nothing but valence, valency. N is nothing but number of non-bonding electrons. Number of non-bonding electrons. Suppose if one lone pair is there, 2. If 2 lone pairs are there, 4. If 4 lone pairs are there, 8. Number of non-bonding electrons. What is BE? Number of bonded electrons. Yet this is not removal electron, added electron. Suppose if carbon is there, what is the valence of carbon? 4. It may be plus or minus. Carbocation, carbanion, valence of carbon is what? 4 only. So V nothing but valency. Ne nothing but number of non-bonding electrons or bonding electrons by 2. That will give formal charge. So after taking this, leave some space, then write down formal charge. So first you write definition, then you write that abbreviations definitely. O2, 2 bonds are present. Already that I given. Here one example I given. First H2 I given, then X2 I given, then O2 I given, then N2 I given. There how many I given? Between two oxygens how many electrons are there? 4 electrons. That and these are different examples. Now I want to reveal this formal charge. That's why wantedly I given 2 electrons. So in order to know the value of formal charge, wantedly I given 2 electrons here. If I write 2 electrons, that example, this example, both are same, no use. Right? First you write down this formula, then write down definition. Right. The charge present on atom of a molecule. Atom of a molecule is formal charge. The charge present on atom of a molecule is called formal charge. Formal charge may be 0, or it may be positive, or it may be negative. Anything is possible. The charge present on atom of a molecule is formal charge. It is represented by Fc. Fc may be 0, positive or negative. But while writing any Lewis-dot structure, it should not be represented by a charge. Okay? Now, just apply this formal charge to N2. First you apply this formula to this one. Here first I am writing first nitrogen. Formal charge of nitrogen. Formal charge of this nitrogen. So what is the valence of nitrogen? This nitrogen. Valence of nitrogen. Is it 3 or not? 3 minus how many non-bonding electrons on this nitrogen? Non-bonding electrons 2. How many bonding electrons? 6 by 2. Then what is the formal charge? 3 minus 2 what? 1. 1 minus, see 6 by 2 how much? 3. Then what is the formal charge? Is it right? Valence electrons, group number. Five minus 2 minus 6 by 2. Group number, valence electrons. Otherwise write group number, nothing will happen. So if I take nitrogen, what is the nitrogen group number? 5. Now you will get 5 minus 2, 3. 3 minus 3, 0. So what is the charge on nitrogen? So same, second nitrogen also you can apply like this. 5 minus 2, 6 by 2, it is 0. So now this molecule, can I write like this? Nitrogen, nitrogen double bond. There is no charge. There is no charge between these two. Clear? Now apply this one. Valence electrons. V nothing but valence electrons of corresponding element with or without charge. Otherwise group number. You write group number better. If you are confusing, write down group number. This is group number, number of non-bonding electrons, number of bonding electrons or valence electrons. Clear? Any doubts? Why you are getting 6 here? Between two nitrogens, 6 electrons are there. You may get one more doubt. Sir, already for this nitrogen I written 6 electrons. Then why you are writing one more time? 6 to this side. Now the 6 electrons belongs to either left side nitrogen or right nitrogen. Both. Here 2 indicates what? Non-bonding electrons. These two are non-bonding electrons for this nitrogen. These two are non-bonding electrons for this nitrogen. That's why written 2, 2. So now group number of nitrogen is 5. Clear? Finally, this is Lewis-dot structure. This is the real structure. You need to write whether having 0 charge or positive or any negative. If there is no charge, we are getting 0, 0, don't write any charge. Leave it. N2, that is the real structure of N2. Now, we'll apply this. What about formal charge of oxygen? See, formal charge of oxygen. Oxygen belongs to which group? 6th group. How many non-bonding electrons on this oxygen? 6 electrons. Minus how many bonding electrons? 2 by 2. Then what is the value? 6, 6 get cancelled. You will get -1. Now this oxygen carry? This oxygen carry which charge? -1. This oxygen carry? -1. So, what is the real structure? O -1, put single bond, O -1. This is the real structure. If I write O -1, how many lone pairs here? If I write O -1, how many lone pair? 3 lone pair. 1, 2, 3. That is the meaning. If you know this structure, you can write Lewis dot very easily. If I write like this, don't think there is no charge. Maybe positive charge is there, maybe negative charge may be 0. Clear? See. So what is the formal charge of oxygens and carbons in this molecule? So it is a Lewis dot structure of which one? Hydrogen peroxide. It is peroxide structure. Suppose if I write hydrogen here, H2O2 or not? H2O2, peroxide structure. What is the formal charge of carbon? Carbon, which group? 4th group. How many bonding, non-bonding electrons? 0 or not? 0 non-bonding. How many bonding electrons? 8 by 2. 8 by 2 means see, +4, -4, 0. No charge. Carbon having no charge. So what is the formal charge of one of the oxygen? Oxygen carry non-bonding electrons. 4. Then 4 by 2 or not? So 6 minus 4, 2. 2 by 2 minus 2, 0. So then what is the structure of this molecule? This is O, CO like this. CO2, no charge on each element. calculate the, I given Levy's dot structure. You write down the formal charges and complete structure. Like this, if you write complete structure, that is the answer. So what is your work? Calculate charge, write down complete structure. Whether any charge comes or not, either plus or minus, anything. First calculate formal charge of this sulfur. What is the charge you will get on sulfur? Sulfur, how many electrons are written? Sulfur, how many electrons are written? 8 electrons. Is there any bond pair electron? If you want to make a bond pair, adjacent should be other atom is required. But right now I am not given any kind of atom. So just say this atom is a alone. Now there is no surrounding atoms. Now calculate sulfur charge. Minus 2. So you can calculate like this. See, formal charge of sulfur is equal to group number 6. How many non-bonding electrons? Non-bonding electrons 8. So there is no bonding electrons, there is no problem at all. 6 minus 8. So this is minus 2. Then when this is given, write down sulfur alone, then write down charge minus 2. So if I write S minus 2, how many lone pairs? 4 lone pairs. If I read S minus 2, how many lone pairs? 4 lone pair. Minus 2 means 2 extra. Minus 1 means 1 extra lone pair. Clear? So how many lone pairs are already present? 2. How many extra lone pair? 2. That is the meaning. So these 2 lone pairs are belongs to sulfur. These 2 lone pairs are generated by sulfur, created by sulfur. But actually these 2 lone pairs belongs to sulfur. This electron belongs to sulfur. This electron also belongs to sulfur. Now this electron pairing with this. This electron pairing with this. These 2 paired by hydrogen. Hydrogen giving 1 electron. One more hydrogen also giving electron. Now H2S converted to S minus 2. Clear? If this is a Lewis structure, it is an exact structure with charge. That is the use of formal charge formula. Now here, what is the formal charge of carbon? Carbon formal charge. 4 minus 8. 8 by 2 or not? 4 minus 8 by 2. 4 minus 4. 0. Now here left side oxygen. 0. And this oxygen. Minus 1. This oxygen minus 1. Right? Carbonato. CO3 minus 2. Here formal charge is minus 1 or not? See. Here how many lone pairs are there? 2. But here 3. How many extra? 1. Here minus 1, minus 1. Here between carbon oxygen how many electrons are there? 2 electrons. That's why single bond. Can you work out this? What is the formal charge of sulfur? 0. So sulfur 0 and here right side double bond O, here double bond O, here one lone pair of electron. So what about oxygen charge? 0. Sulfur trioxide. What about sulfur trioxide formal charge? Sulfur carry double bond O, double bond O, double bond O. No 0. No element having positive charge. Okay, all are neutral. 0, 0, 0. Just calculate this one. Now here, what about formal charge of sulfur? Above, is it double bond or not? Below, double bond. Right side single bonds. 2 electrons single. Here single. Here see 1 extra. Minus 1. Here also 1 extra. Minus 1. Here 0, 0. Sulfur group number 6. 6 minus how many lone pair? 0. How many bonding electrons? How many bonding electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 by 2. 6 minus 6, 0. Clear? Will you calculate formal charge for this or not? Now this one. What about formal charge of sulfur? 0. And below 4 electrons, double bond, right side 1 electron extra. See, 2 electrons are there, single bond. Here also 2 electrons, single bond. Here minus 1, minus 1. And sulfur, what is the charge? Sulfur, what is the charge? 0. How many lone pair? On sulfur, how many lone pair? 1 lone pair. Here oxygen 2 electrons, nitrogen, here 2 more electrons and oxygen. Here I am writing lone pair, here lone pair, lone pair. So what is the formal charge of oxygen and nitrogen in this one? What is the formal charge of oxygens? This oxygen formal charge 6 minus 4 2 2 4 by 2 2 2 minus 2 0. This is 0, this is 0. Okay, so I am writing oxygen, between oxygen and nitrogen double bond, and here nitrogen oxygen double bond. So this is 0 and here also 0. Then what is the charge on nitrogen? See, formal charge of nitrogen, nitrogen carry 5. How many non-bonding electrons? 0. How many bonding electrons? 8 by 2. See this, 5 minus 4. 5 minus 4 means plus 1. So here this nitrogen carry plus, NO2 plus. What is the structure? Overall this structure I can write like this, NO2. So in your examination they will give like this. In NO2 plus, which atom carry plus 1? Either oxygen, nitrogen. Nitrogen. So they will give like this. What is the formal charge of nitrogen? They will ask. Now nitrogen carry plus 1. What about these two oxygens? 0. Now oxygen 2 electron, nitrogen over. What about this? See, this is how many lone pairs present on oxygen? 3. Here, when 2 lone pairs are there, 0. When 3 lone pairs are there, -1. But what about nitrogen? 0 or not formal charge? See, formal charge of nitrogen 5 minus 2 minus 6 by 2 or not? This 2 is this 2 electrons. 6 means 1, 2, 3, 4, 5, 6. Around nitrogen, how many bond pair electrons are present? 6 by 2. 5 minus 2, 3, minus 3. Then how much? That is 0. Then finally, nitrogen carries 0. Right side double bond O, left side minus. So this is 0 and here -1. Here 0 and here 0. So what is the formal charges of oxygen, nitrogen and oxygen in this one? -1, 0, 0. -1, 0, 0. Like that you will ask. Here there is no charge. So that's why I can write 0. And here also there is no charge, 0. Here one lone pair is there or not on nitrogen? Here one lone pair. Here how many lone pairs? 2 lone pair. This is normal structure. If charge is there, you should write charge. But this is in Lewis dot, don't write any charge. You need to represent in the form of electrons only. See, anywhere I written charge here, anywhere I not written charge. Only in other normal structures you can write charge. If I give normal structure, you are in a position to write Lewis dot structure. If normal structure is given like this, you are in a position to write Lewis dot structure. Is it clear? Now, will you work out this? Write down the complete structure of this molecule. So can I write oxygen, nitrogen double bond? Then this oxygen single bond, this oxygen single bond. And here, is it -1? -1. And here, -1. This one, +1. Now what is overall charge? What is overall charge of this molecule? If I condense this molecule, can I write NO3 -1? Is it NO3 -1? Plus minus cancel, only -1 is left. Then see NO3 -1. In NO3 -1, what are the formal charges of oxygens and nitrogen? Like that they will ask. In NO3 -1, what is the formal charges of oxygens and nitrogen? Nitrogen is plus. Oxygen, 2 oxygens are -1, -1. 1 oxygen is 0. But normally if I write NO3 -1, what you will think? Only 1 oxygen carry -1. That is wrong assumption. It is a real structure. It is a condensed structure. Don't remember condensed structure. If you know Lewis dot, then accurate structure you will write with proper charges. Then by balancing the charges, you will write overall charge. Is it clear? So I am giving NH2 minus. Write down Lewis dot structure for NH2 minus. Lewis dot structure for NH2 minus, NH minus 2, N minus 3. Write down Lewis dot structures of these 3. How to write Lewis dot? With charge or without charge? Without charge. Will you write? This is OH minus. OH minus. This is C double bond O minus, carbonato. Write down the Lewis structure of carbonato. Carboxyl cation, this one. Write down Lewis dot structures of the atoms. I can see atoms and electrons only. Don't write bonds. In Lewis dots, don't represent with bonds. Bonds should not be appeared. See, whatever structures examples I given, in that one, especially in Lewis dot, I never given any bond between two atoms. I given only electrons. So you should not write like this. Bonds will not be appeared in Lewis dot. If you see any bond in Lewis dot, that is not Lewis dot structure. Name indicates that represent in a dot form. Any bond pair is there, write down dots. Any shade lone pair is there, write down cross symbol. Will you work out this? Here I will show one example. Nitrogen. First write down nitrogen. Every nitrogen forms single bond with hydrogen. Here 2 electrons, here 2 electrons. Here minus 1 means how many extra? 1 extra. 1 extra lone pair. But already one lone pair is present on nitrogen. It is a real structure of this one. Lewis dot. So if you calculate formal charge in this one, you will get minus 1. See. Nitrogen group number. Formal charge of nitrogen I am calculating. Nitrogen 5. Now how many non-bonding electrons? 4. Then how many bonding electrons? 1, 2, 3, 4. So 4 by 2. So then 5 minus 4. 1. 1 minus 2. 1 minus 2 what? Minus 1. Whether you retain right or wrong, that can be confirmed by formal charge formula. Clear? Now, will you write this? In NH minus 2, how many lone pairs are present? How many lone pairs? 3 lone pairs. So, nitrogen, 1 lone pair, 1 bond pair with hydrogen, and here already 1 lone pair is present, and here 1 extra, here 1 more extra. Clear? So, how many lone pairs are present? 3. Will you work out this? How many lone pairs? 4. Write down 8 electrons with cross symbol. Now this one. Here hydrogen, oxygen is present. Right. 1 lone pair, 2 lone pair, 3. Right? Will you work out this? How to write this one? Little elaborate you need to do. Here 2 electron, 2 electron, 2 electron. Don't write any bond, don't write any charge. Between these two, 2 electrons. And here 4 electrons. Here oxygen. Here 2 electrons oxygen. Then 1, 2, 3, 4, and here 1, 2, 3, 4, like this. Don't write any bond. This you need, it will take some time. You write clearly. Write every individual carbon clearly like this. So carbon 2 electrons, oxygen 1, 2, 3, 4, 5, 6, and carbon 2 electron, carbon 4 electron. Here one carbon is there. This carbon, how many electrons? 4 electron. And here one more carbon. Here how many? 2 electron. Here carbon. Here this is carbon, and here one more carbon. So here how many electrons are present? 2 electrons. And here 1, 2, 3, 4. And here 2 electrons. Between carbon and hydrogen, here hydrogen is there or not? 2 electrons. Here 2 electrons. 2 electrons. It will take some time. Little bit expand form. Like this you should write. Don't try to write any bond. Don't write any charge in Lewis dot. Only dots. With respect to dots, you need to confirm that whether it is a charge or not. So just write down this and leave it. You work out this later. The formal charges of nitrogen and oxygen atoms in following are. What is your answer? +1 and -1. Apply the formal charge formula, you will get the answer. Very easy. Here see, no lone pair, but additionally 8 electrons are there. So nitrogen 5 minus 0 minus 8 by 2. 5 minus 4 you will get +1. The formal charges of 3 oxygens in ozone. What are the formal charges of 3 oxygen in ozone are? 0, 0, 0, -1, +1, -1, minus 1 plus 1 0. Minus 1 0 plus 1. This is CSR question. Even in gate also repeated. Ozone. In ozone, what are the formal charges of 3 oxygens? Ozone having how many oxygens? 3. O3. O3. Any charge is there on ozone? O3. O3 minus 1, O3 minus 2 or minus 3? No charge. 0. O3 0. So if O3 having overall 0, is it real 3 oxygens having 0 charges? 0 0 0. So this is oxygen, electron, here oxygen and this one. This is the Lewis dot structure of ozone. Then calculate. Very easy. If oxygen carry 3 lone pair, what is the charge? Minus 1. If oxygen carry 2 lone pair, 0. If oxygen carry 1 lone pair plus 1. So I can write oxygen, single bond is there, here double bond is present. So now, here they carry minus 1 plus 1, 0. Minus 1 plus 1, 0. Otherwise apply the formula, formal charge formula, you will get this. Clear? So that's why plus 1 minus 1, 0. Overall is 0. So don't think that 0 0 0. So that is about formal charges. So that is about calculation of sigma, pi as well as identification of lone pairs. Okay. So today morning I sent some questions in your WhatsApp group. A selective area of calculating hybridations and also calculating sigma bonds, pi bonds, hybridations, linearity, planarity, everything is given in that one. Just go through it, write down it one place. If you don't have patience, you take Xerox. But my suggestion is if you write it one place, that will give some additional practice for you. Okay. So up to Lewis dot structure you work out. So later on upcoming topics such as homolytic fission, heterolytic fission, electrophile, nucleophile, amphiphile, then followed by inductive effect, mesomeric effect. Only one more class is required to complete almost all 80% in that one. That whatever PDF I send, in that one you can work out up to 10 pages. 10 pages you can work out very easily. Up to covered syllabus, what I am saying. So write down it one place, otherwise you take Xerox, try to work out that particular questions without watching key. Okay, if any free time is there, on that time we are going to discuss it time. But if any bulk information I given regarding any questions, so calculate the hybridations of following molecule or bulk molecules are given. So that is not going to be explained. Because bulk molecules are given, if you have any doubt, you can ask me after the class. That is only for practice point of view I given. But if any choose the correct answers I given. Okay, which among the following is electrophile? So out of this particular molecule, which nitrogen carry hybridation sp3 like that? That questions we are going to discuss in class. Clear? First you work out that questions. Still if you have any doubt, you can ask me after the class. Okay, we'll stop here. So tomorrow timings 5 to 8, organic and inorganic.